Hey guys, this lesson today is lesson 5.2a. It is a lesson on proportions. You'll notice that this lesson is not one that you'll find in our textbook, but it is something that is very important and ties right along in with what we've been learning about ratios. So at this point, you should have already watched the Math Antics video all about proportions and learned a little bit about how to cross multiply to solve for an unknown, or what we call a variable. So think back to those terms like variables that we learned about a couple of chapters ago. A little bit of algebra is coming back, and we are going to tie the concept of algebra and solving for variables with a lesson on proportions today. So we'll take a look at this example here first before doing these examples together. All right, so we have a proportion here. It's 5/8 equals n/4. Whenever we have a fraction equaling another fraction, when one part, any of these four parts, has an unknown or a variable, we do something called cross multiplication. Cross multiplication is basically how they set up these arrows here. We take the bottom number on the left side and multiply it by the top number on the right side, and the bottom number on the right side and multiply it by the top number on the left side. It doesn't matter which one you do first. You could do the top on the left times the bottom on the right first, just like they did here, and then you're always going to continue that equal sign down so that it equals the cross multiplication of basically the opposite of whatever you did first. So since we started with our 5 times 4 here, we are going to set that to equal 8 times n here. This process is called cross multiplication, and it only works when we have a fraction equaling another fraction with one of these four locations being an unknown or a variable. All right, so we take our 5 times 4 and set it equals to 8 times n. When we have 5 times 4, that equals 20, equals 8n. Now, this is something that's familiar from a few chapters ago, learning about algebra and solving for variables. Think what we have to do now to get n all alone over here on the right-hand side. Right now, n is being multiplied by 8. Think back to that concept of inverse operations. Inverse. Since n is being multiplied by 8, we now need to divide each side by 8. Remember, it's like a scale. An equal sign is like a scale, and whatever you do to one side of the equal sign, you do to the other. So from this step to this step, we divide each side by 8. Since we're dividing 8 times n divided by 8, these 8's cancel each other out because 8/8 equals 1, leaving us with just one n. Now, because we multiplied this side by 8, divided this side by 8, we have to be sure to divide this side by 8. Whatever we do to one side, we must do to the other side. So we end up with 20/8 equals n. 20/8 equals n. Now in this particular example, it kind of looks like we missed a step here. One thing I would include right in here would be 20/8 equals n before moving down to this step where we say reduce. Since 20/8 is a fraction, it's not in simplest form, we must reduce that fraction. I can take a look at 20/8 and think, what factors do these two numbers have in common? Well, we know that they both are divisible by 4, so we can divide the top and the bottom by 4, and we end up with the equivalent fraction of 20/8 to being 5/2. So 5/2 equals n, and that would be what n would equal up here for this proportion lesson. We could even take this a step further, and seeing that it is a improper fraction of a larger number over a smaller number, 5/2, we could actually even convert it into a mixed number. 2 goes into 5 how many times? 2 times. With how many left over? Well, 2 times 2 is 4. 1 left over to get 5. Keep my denominator the same. 2.5 equals n, which is the same thing as 2.5. So this n up here would then have 2.5 or 2.5 or 5 over 2 all be the correct answer to make it an equivalent proportion or an equivalent fraction from this 5 over 8. Let's take a step down here into example number 1. There's 3 parts, all 3 different problems, and we'll use the same concept of cross multiplication in order to solve for our unknowns, or x in this first case. So we see that we have 4 over 9 equals 10 over x. Remember, we're going to cross multiply, going with our 9 times 10 equaling our 4 times x. Remember, it doesn't matter if we do 4x first or 9 times 10 first. It doesn't matter which one. I'm going to start with my 9 times 10 equals, remember we always bring down that equal sign, 4 times x, or just 4x. Remember, we don't need a multiplication sign between a coefficient and a variable. 9 times 10 equals 90. I want to keep everything in line, keep my equal sign right below the one above it. So 90 equals, I can't simplify this anymore, equals 4x. What's happening here to x? Well, x is being multiplied by 4. I want to do the inverse operation to get x alone. Whatever I do to one side, I have to do to the other. To get rid of that 4, I want to divide each side by 4. My 4's cancel out, and I end up with 90 over 4 equals x. From this point, we have a couple different options. I'm actually going to continue my work up over here. So I have 90 divided by 4 equals x, because x is all that's left on this side. I can do a couple different things. I can simply divide 90 divided by 4 and show my work off to the side. 4 goes into 9 2 times. I get 8. 1, bring down my 0. 4 goes into 10 2 times. There's a decimal point now. Oh, there we go. And 4 times 2 is 8. Bring down this invisible 0. 4 goes into 25 times. I end up with 22.5. So 22.5 equals x. I could have also just plugged that into my calculator, 90 divided by 4, and I would get 22.5. Now, we don't want to forget our check. Remember, anytime we solve for a variable, it's very important to do an ESS check. Our E, remember, it stands for the original equation. 4 over 9 equals 10 over x. My S would be 4 over 9 again. I want to rewrite everything because I'm substituting now. This S stands for substitution. 10 over, well, I found 22.5 to be what x equals. And I circled that right here. And if I were to then plug this into the calculator, I would end up with 4 divided by 9 gives me roughly 0.44. 10 divided by 22.5 gives me roughly 0.44. Since both sides are balanced and they equal each other, I would give that a check and know that my 22.5 equals x is correct to make this proportion equivalent to each other. All right, let's continue with the next one. We have 21 over 27 equals x over 18. Remember, I want to cross multiply. It doesn't matter if I do 21 times 18 first or 27x first. This time I'm going to start with my variable on the left-hand side. So 27 times x is just 27x. Remember, we need to set it equal to our cross multiplication the other way, 21 times 18. Bring down my 27x because there's nothing I can do there. In the calculator, if I type in 21 times 18, I end up with 378. Now I see that my 27x, we're having multiplication over here. In order to get x alone, my inverse operation would be to divide each side by 27. Bring my x down, see if I can write kind of small here. In the calculator, if I do 378 divided by 27, I end up with x equals 14. And that would be my final answer. Now if I want to check that answer of x equals 14 right here, I'm actually going to do this one in a different color. Make things a little bit easier. All right, so my check here for this problem, ESS 21 over 27 equals x over 18. 21 over 27 equals, I found that 14 is x. Substitute that in. And if I plug these two numbers into the calculator, I get roughly 0.78 equals 0.78. So I must be right. Now hopefully you are not running out of room like I am. I'm actually going to take this problem here, 350 over p equals 1050 over 60, and to show my work a little bit lower on the screen. Hopefully your writing's not as big as mine. 350 over p equals 1050 over 60. Let's do this one together. So we're going to cross multiply. We can start with our 350 times 60 or our 1050 times p. Either one works. Let's do, this time we'll start with just our numbers. 350 times 60 equals 1050 p. 350 times 60, if I throw that in the calculator, I end up with 21,000 equals 1050 p. I want to solve for this p. In order to do that, I have to divide each side by 1050. They cancel each other out. Divide this side by 1050. If I do 21,000 divided by 1050, I end up with 20 equals p. Notice that this time I just kept my equal signs coming straight down below each other. I simply brought down everything on the right hand side that was left. All I had left over here was p. When I solved 21,000 divided by 1050, I ended up with 20, so I stayed in that straight line. In order to check this problem, we'll do our check over here. 350 over p equals 1050 over 60. Just a reminder for you guys, remember the first step in our ESS check is to simply rewrite the original equation. Second step, we're going to substitute in for p. We found that p is 20, so 350 over 20 equals 1050 times, oh, that doesn't really look like a 50, does it? Let's rewrite that. 1050 over 60. And our goal here, remember, is to get this side to equal whatever is on this side. If it's not equal, then we know that something went wrong here. If this number doesn't make each side balanced, then we need to go back and check and see if we did something wrong. If we plug into the calculator 350 divided by 20, we end up with 17.5. Plug in the calculator 1050 divided by 60, and we end up with another 17.5. So these are balanced on each side of the equation, meaning when we solved for p to be 20, we found a equal proportion. So 350 over 20 gives us something that equals 1050 over 60. So that's it for solving for variables when we set up a proportion. As long as you understand how to set up the proportion and cross multiply, you should be good to go. Please, please, please come see me if you have questions. If you have any issues with the homeworks, we can discuss it in advisory, homeroom, during class. Just let me know. And I hope you guys have a great rest of your day. See ya.